In this lecture, we're going to learn about function template return type deduction with auto. This is going to be an extension to what we did in the last lecture. We saw that we could specify multiple template parameters for our function. That could work really well, but we were struggling to have a way to specify the return type for our function here, for example, which computes the maximum between two arguments that are passed to it. We saw that it was bad design to use one of the parameters to the function as the return type, because the return type then would depend on the order of the parameters you call your function with. After that, we saw that we could set up a separate template parameter for the return type, and this worked pretty well. And we saw that we had much more flexibility if we put the return type first in our template parameter list. In this lecture, we're going to see that we have another way, which is arguably simpler than what we saw in the last lecture. And that is using return type deduction with auto. We can set up our function like this. We're going to say template and specify our two templates, T and P. We can do that. And then tell the function to deduce the return type. What this is going to do, it's going to follow some rule to get the return type out of this function. And the rule is the largest type is going to be deduced from the arguments you pass to the function when you call it like this. For example, here we are calling the function with a double literal. This is going to be of double type, and we have an int literal. We know that double is larger than int in memory, so this is going to deduce the return type to be double, because in our expression to compute the return type, double and int types are involved here. This is the rule that is going to be used, and you can use this to make your function template simpler if you want to deduce the return type. Okay, this is a simple example of that. Down here we see that we are passing in a character type and an int type. So int is larger than character, so we're going to return int. That's what is going to be deduced. And if we print this out here, we should see a 4 as the type of the return type, or the size of the return type, I should say. This is how we can use auto type deduction with templates. And the rule is really simple. The largest type for the arguments that you pass is going to be used as the return type if you use this syntax here to set up your function template. Okay, another thing I want you to see is that we can force the return type on the compiler indirectly. For example, we can specify our template arguments, I should say explicit template arguments here, and the largest of these two guys is going to be the return type. For example, if you specify int and double, double is going to be the return type, but that's not going to be coming from the parameter list. That's going to be coming from your explicit argument list. Okay, that's the difference here, and I really want you to be aware of this. If you think this is going to help your application, please take advantage of this. It is going to work. The last thing I want you to be aware of is that if you are using auto return type deduction, the definition has to show up before the point where you call the function. And we have seen this before, but it is also going to be the case if you are using function templates. So in most cases, any kind of return type deduction you're going to do from your function is going to require for the function definition to show up before you call your function, because the compiler needs to look at your return statement to deduce the return type. If it doesn't see your function definition, it's not going to be able to see this, and the function definition has to show up in front. This is something you need to be aware of. Now that you know these little things, we're going to head over to Visual Studio Code and actually play with this a little more. Okay, here we are in our working folder. The current project is template return type deduction with auto. We're going to grab our template files pretty quick. We're going to copy them. We're going to put them in place, and we're going to open our folder here in Visual Studio Code by dragging and dropping here. This is going to open our folder. We have our main CPP file here. We can clean it up a little bit, and we're going to specify our maximum function here. So we're going to say template, and we're going to say type name T, type name, and we're going to specify our return type to be auto. So we're going to do auto return type deduction. We're going to call our function maximum, and we're going to specify the type t as our first parameter and the type p as our second parameter. And we're going to do what we've been doing all along, return a greater than b. If a is greater than b, then that's going to be our maximum. If it's not, b is going to be our maximum, and we're going to return this. Now that we have this, we can try and call this function, and we're going to see the behavior. Okay, so we're going to jump down in the main function here and put in some code to play with. Before we really play with this anymore, we need to make it clear what are the rules for return type deduction with templates here. And that is, the largest type is going to be deduced. Let's say that here. And what we mean by this is the largest between the types that are involved in the return expression here. And here you see that a and b are involved. So the largest of these two is going to be deduced as the return type. In our call here, we are specifying the first parameter to be a double literal, and the second parameter is specified to be an int literal. So the double parameter is larger. Our expression here is going to be deduced to be double, and the function is going to deduce a return type of double here. And we can print the size of this, and we're going to really prove this. So let's try and build this program. We're going to use GCC to do this. The build is good. We can clear, not clear. We can bring up a terminal before we do that. And we're going to clear now, run rooster. We're going to see that the maximum is 33, and the return type was deduced to be double because the size of that is 8 here. Hopefully you can see this. Let's try and see if we can see more information on this by debugging. So we're going to set up a breakpoint on the call to the maximum function here, and we're going to hit the run tab here, and we're going to hit the green button to start debugging. This is going to build our application, and then it's going to pass that through the debugger, and we're going to hit the breakpoint here. The moment we do that, we have the option to step into the function call here. So let's do that. We're going to hit step into. This is going to jump into the function. And now you see that we don't really have a way to see the return type information. This is not showing the return type. We just see the two parameters that are passed to the function here. So debugging isn't really any more helpful, but we can rely on printing the size information to know the actual type that was deduced as our return type here. If we change these two guys, for example, to be a character type and an int, let's say E, for example, here. So this is going to be a character type. So this is going to deduce int because int is larger than the character here. So let's say int is going to be deduced in this case because that's the case. So let's build. We are going to use GCC to do that. The build is going to go through. Let's take out the left pane. We don't need it anymore. And if we run rooster, we're going to see that the return type is going to be deduced to be int. The size of that is 4 bytes in memory. And you see the maximum is 101 because that's the integer representation for the character E in our ASCII table. If we go in our favorite search engine and say ASCII table, we're going to have many entries. If we click on the first one here, we're going to see that 101 is representing the E character, as we can see right here. Okay, so this is what we're getting printed on our terminal. So this is really how return type deduction is going to work if you set up a function template like this. The other thing I want you to see is that you can even specify your own template argument list. So you can come after the function name here and, for example, say, I want my first parameter to be double and I want my second parameter to be int, for example. You can say this if it makes sense for your application. And what is going to happen, the compiler is going to be forced to use these types for T and P. So T is going to be replaced by double, P is going to be replaced by int, and the compiler is going to do any necessary implicit conversions from the function arguments that you pass here. So the E here is going to be turned into a double, The 33 here is going to be turned into an int. It is an int, so no need for any transformation. But the return type now is going to change to double, okay? Because that's what we are specifying here. Your template argument list is going to take precedence over your function parameter list. So double is going to be our return type here. And if we print that, we're going to see that now this is going to say 8. And the maximum is going to be a representation of double for this integer we have in here. And it's probably going to say 101 again. Let's build again, and we're going to see this build successfully. We can clear and run rooster. Now we have maximum is 101, and the size of the return type is double because that's what we are specifying right here. Okay, the last thing I want you to see is that if you are trying to split your function into declaration and definition, return type deduction like this is not going to work. Let's put this in place. And we're going to put our function declaration on top here. So let's take out the body. And now, if we try to compile this program, let's see what we get. We're going to compile this and not specify the template argument list because that's helping the compiler out. Now we want the compiler to deduce the return type based on the information we have in here. Let's try and build this program and see what we get. We're going to get a compiler error. And the compiler error is saying use of auto maximum before deduction of auto. And what this really means is that the compiler needs to see the definition of the function to be able to deduce the return type. If the definition shows up after the point where you call the function, you're going to get a compiler error because the compiler has no way to deduce your return type. If we take this and put it back in front of the main function, you're going to see that this is going to work. So let's build again and build with the GCC. You're going to see that the build is going to be good because the compiler now can deduce our types. Okay, this is really all I set out to share with you in this lecture, showing you how you can do return type deduction with auto. Now you know that you can use this to avoid what we did in the last lecture by specifying a separate template parameter for the return type, but know the rules. This is going to be using the largest of the types that you pass as parameters to the function to deduce your return type. And the largest type is going to be deduced to be your return type here. We are going to stop here in this lecture. In the next one, we're going to see how we can use decal type and trailing return types to make things easier in what we are doing here. Go ahead and finish up here and meet me there.